Hi students and friends, welcome to the channel Learn and Teach by Sir AYAZ. I'm your teacher and host Sir AYAZ, and I'm going to continue my past papers for IGCSE Chemistry, that is 0620. And this time I have selected October-November 2023. Variant is 63. You know the other details that the paper is of 1 hour and you have to answer all the questions. You may use a calculator. Total mark for this paper is 40. Important thing, notes for use in qualitative analysis are provided in the question paper. So these are the notes for use in qualitative analysis. You will use these notes. You have test for anions, test for cations, you have test for gases, and the last one, that's flame test for metal ions. Let's start the paper. Here's question number 1. Hydrated aluminium chloride is a white solid. When heated very strongly, hydrated aluminium chloride produces steam, hydrogen chloride gas, and aluminum oxide. Hydrogen chloride gas is toxic and aluminum oxide is a white solid. A teacher heats a sample of hydrated aluminum chloride using the apparatus shown in figure 1.1. Here's figure 1.1. You see hydrated aluminum chloride. You have heat source and the instrument used or apparatus used is labeled as A. Part A. Name the item of apparatus labeled A in figure 1.1. It's known as crucible, so you write crucible here. B. Explain why this experiment should be carried out in a fume cupboard. You see here, hydrogen chloride gas is produced in this experiment. Hydrogen chloride gas is a toxic gas. So what you write, hydrogen chloride is toxic, simply. Part C. The hydrated aluminum chloride has to be heated very strongly to describe how a Bunsen burner is adjusted to make the flame as hot as possible. Which means you must have maximum supply of oxygen present in the air. So you must have air hole fully open. Part D. During the experiment, the mass of apparatus A and its contents decreases. Explain why the mass decreases. If you look at the experiment, what is produced? You have two gases produced here. It's also a gas, steam, the gas, and hydrogen chloride. It's also a gas. So you can write either gas or mention the name of gases. You can write steam or hydrogen chloride, leave or escape. You can even write gases leave or escape or lost in the surrounding. Steam and hydrogen chloride gases are released. Part 2. Describe what the teacher can do to be sure all the hydrated aluminum chloride reacts. So what the teacher can do, teacher should reheat until weight or mass becomes constant. So you write reheat the solid until mass is constant. Moving to next part E. In a second experiment, the teacher uses the apparatus shown in figure 1.2 to collect the water made. We have hydrated aluminum chloride, we are heating it, and you are having waste gases, then you have ice in the beaker. 1. Explain the purpose of the dry ice. Definitely so that the steam or vapor condenses. In order to condense steam. You have steam produced, you have to condense the steam. Number 2, the water collected is not pure. Describe a test the teacher can do to show that the water collected is not pure. State the result of the test if the water is not pure. The simple test in order to check the purity, so you will measure boiling point or freezing point. So I will write measure boiling point. Result should be 100 degrees centigrade. Next question, that's question number 2. A student investigates the reaction between dilute hydrochloric acid and aqueous sodium hydroxide. The student does 2 experiments. We have experiment number 1. Fill a burette with aqueous sodium hydroxide and run some of the aqueous sodium hydroxide out of the burette so that the level is on the burette scale. Record the initial burette reading. Use a measuring cylinder to pour 25 centimeter cube of dilute hydrochloric acid into a conical flask. Stand the conical flask on a white tile. Add 5 drops of methyl orange indicator to the conical flask. Slowly add aqueous sodium hydroxide from the burette to the conical flask while swirling the flask until the solution just changes color. Swirling means shake. Shaking, mixing. Record the final burette reading. Experiment number 2. Empty the conical flask and rinse it with distilled water. Refill the burette with aqueous sodium hydroxide. Record the initial burette reading. Use a measuring cylinder to pour 25 centimeter cube of dilute hydrochloric acid into the conical flask. Add 0.5 gram of calcium carbonate powder to the conical flask and swirl the flask. Stand the conical flask on the white tile. Add 5 drops of methyl orange indicator to the conical flask. Slowly add aqueous sodium hydroxide from the burette to the conical flask while swirling the flask until the solution just changes color. Record the final burette reading. Part A. Use the burette diagrams in figure 2.1 and figure 2.2 to record the readings for experiment 1 and experiment 2 in table 2.1 and complete table 2.1. Experiment 1. What we have initial reading and final reading. Initial reading, if you count it, it is 0.6. What about the final reading? It's 19.2. I'm writing the readings for your convenience so we can note it down later on. This is experiment 1. So experiment 1. So initial reading 0.6, final reading 19.2. Check it again. Fine. So experiment 2, initial reading, it is 1.5678. 1.8. What about the final reading? It's exactly 8. So for experiment 2, you have 8 final reading and 1.8 as initial reading. Now volume of aqueous sodium hydroxide added. For experiment 1, 19.2 minus 0.6. 18.6 for experiment 1. What about experiment 2? 8 minus 1.8. You'll get 6.2. Note down these values. Moving to next part. B. State the color change observed in the conical flask at the end point in both experiments. Now, in the conical flask, we have taken hydrochloric acid. Hydrochloric acid in conical flask in both the experiment. So, we have added aqueous sodium hydroxide into conical flask. So, color must be in acid. Initially, it was an acid. Then you have excess of alkali. The change will be due to the presence of excess drops of alkali. So it must be in acid. The color is red. In case of alkali, it changes to orange. This is something you have to learn by heart. 1.5 gram of calcium carbonate is added to the conical flask in experiment 2. A gas is produced. You see, you have a calcium carbonate. So you see calcium carbonate. And when it's added to conical flask, this conical flask contains hydrochloric acid. It's a reaction between metal carbonate and acid. So whenever metal carbonate reacts with acid, a gas produced is carbon dioxide. So you write CO2 or carbon dioxide simply. D. In experiment 2, the conical flask is rinsed with water, but the burette is not rinsed with water. One state why there is no need to rinse the burette with water, because the concentration of the NaOH used is same. The concentration does not change. Same concentration of sodium hydroxide is used. Part 2. Explain why the conical flask is rinsed with water. Now, the purpose is to remove the impurities. To remove impurities. Part 3. The conical flask is not dried after being rinsed with water. State how drying the conical flask affects the volume of aqueous sodium hydroxide needed to reach the endpoint. Explain your answer. There will be no change because water does not change amount of acid added, amount of acid used. So you write, there will be no change. Water does not change the amount of acid used. Because it's in excess. We are using measuring cylinder. It's in excess. Acid is in excess. Even compare the volumes of aqueous sodium hydroxide needed to reach the end point in experiment 1 and experiment 2. You see this clearly in experiment 1 and experiment 2. In experiment 2, the volume is high. In experiment 2, it's low. So we will write more in experiment 1 and mention the values. More in experiment 1. Experiment 1, you have 18.6. Experiment 1 and 6.2 in experiment 2. Part 2, explain why different volumes of aqueous sodium hydroxide are needed in experiment 1 and experiment 2. The reason is that in experiment 2, hydrochloric acid is first reacted with calcium carbonate. So you write in experiment 2, calcium carbonate reacts or neutralizes some of the acid. Part 3, calculate the volume of aqueous sodium hydroxide needed to reach the end point of experiment 2. If experiment 2 is repeated using 0.25 gram of calcium carbonate instead of 0.5 gram. Now see, in experiment 2, when 0.5 gram is used, so the volume is 6.2 is of NaOH. So if you will decrease this mass, that is 0.25 gram, you have decreased, you have actually halved the mass, so the volume of sodium hydroxide will get doubled. 6.2 multiplied by 2, then we need to multiply 6.2 by 2 in order to get the volume of aqueous sodium hydroxide used here. So 6.2 multiplied by 2, what you will get? 6.2 multiplied by 2, we get 12.4. Then it must be 12.4 centimeter cube. That's very simple because initially they have used 0.5 gram. Now they have half the mass because the calcium carbonate, it's reacting with hydrochloric acid. Now half the mass will react. So the volume of NaOH utilized will get doubled. So that's why I have multiplied 6.2 by 2. F, describe how the reliability of the results obtained can be confirmed. You can repeat the experiment and compare the results. Moving to next question. Question number 3. A student tests two substances, solid I and solution J. Test on solid I. Solid I is chromium 3 sulfate. The student dissolves solid I in water to form solution I. The student divides solution I into 3 portions. Complete the expected observations. A. To the first portion of solution I, the student adds aqueous sodium hydroxide dropwise until it is in excess. Observations, adding dropwise observations in excess. You see, you have chromium 3 sulfate here. So aqueous sodium hydroxide, the test is used to check the presence of positive ions. This is a test for the cations here. So we must have Cr3 plus ion, and with aqueous sodium hydroxide will give green precipitate, which is soluble in excess. So you write green precipitate. Observation excess dissolves because soluble in excess. Part B. To the second portion of solution I, the student adds about 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous silver nitrate. Observations. Now, the solid is chromium 3 sulfate, and this is test for the anions, and you see the test for the anions. If you look at the test for the anions, you have 3 ions here. These are tested with initially their solution is acidified with dilute nitric acid, then aqueous silver nitrate is added. So there's no change, which indicates what? So you'll write no change because this test is the presence of for the presence of chloride, bromide, iodide. We don't have chloride, bromide, or iodide. So you write no change or no precipitate. No change or no precipitate obtained. Part C. To the third portion of solution I, the student adds about 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous barium nitrate. Observations. Now here we have chromium 3 sulfate. The test must be of the sulfate ion. If you look at the test for the sulfate ion, you have to acidify it with dilute nitric acid and then aqueous barium nitrate is added. The result will be white precipitate. So you write white precipitate here. Now, test on solution J. Table 3.1 shows the test and the student's observations for solution J. The student divides solution J into 5 portions. In test 1, use a glass rod to transfer 1 drop of the first portion of solution J onto a piece of universal indicator paper. The universal indicator paper turns red. Test 2, to the second portion of solution J, add a piece of magnesium ribbon. Test any gas produced. The piece of magnesium ribbon disappears and effervescence is seen. The gas produces a pop when tested with a lighted splint. Test 3. To the third portion of solution J, add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate, white precipitate in observations. Test 4. To the fourth portion of solution J, add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. No change. Test 5. Do a flame test on the fifth portion of solution J, lilac colored flame. Before proceeding, I'm going to give you a brief indication of what is happening here. So if universal indicator per paper turning to red, it indicates it must be acid due to H positive ions. That's why it's turning red. And the second portion, there's a reaction with magnesium ribbon. It indicates the acid is reacting with magnesium ribbon. And whenever metal reacts with acid, what you'll get? You'll get salt plus hydrogen gas. So this gas must be this one because they are saying the test. The gas produces a pops sound when lit. Third portion, they are saying nitric acid followed by few drops of aqueous silver nitrate. If you look at the list here, look at the list of the anions, you see the test. This is of chloride ion. It gives white precipitate. So it must be having chloride ions, Cl negative ions. What about fourth? To the fourth portion of solution J, add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. They are saying no change. So this is a test for the presence of sulfate ions. See, nitric acid is added, then aqueous barium nitrate is added. And it must show white precipitate, but it's not there. So sulfate ion, SO4 ions are absent. Last, do a flame test on the fifth portion of solution J. You see lilac colored flame. If you look at the list of the flame test, here's the list of the flame test, lilac color. It's of potassium ion. So it must be having K plus ion. So suggest a pH of solution J. So we have H positive ion, Cl negative ion, and K plus ion. H positive and Cl negative means it must be HCl. which is a strong acid. So the pH of HCl is between 1 to 3. So it must be between this range. Identify the gas given off in test 2. So I've already told you the reaction is happening. They have mentioned the test. It's of hydrogen gas. So you'll write H2 or hydrogen gas. F. Identify the 3 ions in solution J. So we have 3 ions. These are the 3 ions we are having: H positive, Cl negative, and K positive. Moving to next question. This will be the last question. You are asked to investigate the effect of temperature on the rate of decomposition of aqueous hydrogen peroxide. Aqueous hydrogen peroxide decomposes to make oxygen gas. Here's the reaction. You see, hydrogen peroxide is a liquid. You're getting water liquid and oxygen gas. The reaction is very slow unless a catalyst is added to the hydrogen peroxide. Manganese oxide is a catalyst for this reaction. Plan an investigation to find how the temperature of the aqueous hydrogen peroxide affects the rate of the catalyzed reaction. Your answer should include an explanation of how your results will tell you how the rate of reaction has changed. You are provided with aqueous hydrogen peroxide, manganese oxide, and common laboratory apparatus. Now let's see the marks for this question. The marks for this question is 6, and they didn't give you any. They didn't ask you, I mean, to draw any diagram. So no need to draw diagram in this question. So this investigation question. So you can write any 6 from these. So you have 2 scenarios. You can either measure volume of the gas produced, investigating the rate, or measure the change or loss in mass, because gas is released. Oxygen is a gas. It's a gas released in the air. You can measure the loss in mass, because mass will decrease when the gas is released in the atmosphere. So few points are common for both of these investigations. You will always start with the known or stated volume of H2O2. Known volume of H2O2. And you will always add known mass of catalyst. In both the experiments, add known mass of catalyst. It should also be same for all these experiments. Then, yeah, you are doing this reaction in a suitable container. Name the container. Reaction done in a suitable container. Like what? Like test tube or boiling tube. Okay. Now, for this step, you have 3 steps. These are the some common steps. Now, if you are doing this for investigating the mass loss, so initial 3 steps will be same, but the 4th step will vary. In case of if you are investigating the loss of that is the change in volume, then you write collect gas in a gas syringe. I'm writing the name of the apparatus. The marking key says suitable container. It must be gas syringe, or you can have place apparatus on balance, or place in order to investigate the loss now. Place the apparatus on beam balance. Now, next step, in case of gas, you will measure volume after set time. Measure volume of gas after set time or measure mass lost, or measure loss in mass again after set time. Then you will repeat these steps at different temperatures. Repeat these steps at different temperatures. So for the gas, you will have higher volume in set time means faster rate. Higher volume of gas in set time means faster rate. Or you can have shorter time means faster rate also. So for the mass, or you have higher loss in mass in set time means faster rate, or higher loss in mass in set time means faster rate. You can even at this point repeat. It's already mentioned. Repeat the steps at different temperature. So you have any 6 of these. You have 1, 2, 3, 4, 5, 6, 7. So you have any 6 of these steps. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.